Hello. In this video, we'll be going over setting up signals, virtual signals in your project. So, as always, we are starting from our video example here. If you don't have that open, you can open the project and go to your project location and open the project.g3p file, as we've done in previous videos. So once that's open, the signals, or to set up signals in your project, which we've already looked at how to set up J1939 signals, so now we're going to go in here and set up virtual signals. So we can scroll over this sort of gray and green box, and as we do that, it says Signal Editor. So we'll go ahead and select that. So in this case, we have certain tabs up here. The J1939 RX signals, virtual signals, diagnostic signals, and system signals. Each of these will be a separate video. So in this video, we're talking about virtual signals. If you've selected an advanced project, there's already some signals added here. If you've selected the advanced, I would recommend not messing with these signals. They're used in the project behind the scenes. So we won't mess with these. If you've just done a basic project, then this signal list will most likely be blank. All right, so virtual signals. Virtual signals are, let's first add one, that way we can talk about it as we go. So we add it, and usually it will take a signal name that it doesn't already have. So sometimes it starts fairly arbitrarily. In this case, we're just going to give it a name that we want to use. So we'll just say signal custom 1. Okay, now virtual signals are signals, they're holders for data in your project. So if you're used to programming in other languages, such as like C++ or really any other programming language, they have something called variables in those languages. So variables hold data. Virtual signals are essentially variables in the QuiC tool. So these are signals that we set up to hold any sort of data we want in the tool itself. So our signal name is signal custom 1, and our data size is defaulted to 1. Now we probably will want something more than 1. So let's use this calculator here. So let's say we want to hold a signal, and that signal or value can be anywhere from 0 to 100. So if we look over here in the data range, this is where we specify the range of the value that we want. So right now our min is 0, our max is 0. So let's make this a maximum of 100. So we can say, okay, this variable can hold something, any value from 0 to 100. Our default value, right now is 0, and I think we'll keep it at that, but we could say, okay, we want it, if we never set this variable to anything, we want it to be a default value of 10 or 20 or really anywhere within the range. I think if we go outside of the range, it's going to give us an error and say, well, your min and max was 0, 100, and you selected a default value of 101, which doesn't make sense. So we'll keep it at 0 here. Our offset and bit weight. So our offset allows us to have essentially a negative number, and our bit weight allows us to have decimal points. So we talked a little bit about offset and bit weight in the J1939 signal video. But let's say our bit weight is 1 and we have a min value of 0 and a max of 100. If our bit weight is 1, that's saying we have 100 bits. So for this we need a calculator. It gets a little complicated. So right here we have a data size in bits. Okay, so if our data size is 8 bits, all right, if we can come to here, and anyone familiar with how to calculate bits or data size, I won't get into this too much because it can really spiral into a much bigger video, but we can go 2 to the 8 bits, and that allows us to represent 256 different values with 8 bits. So we could potentially have 0 to 255. So 0 is 1, and then 255, so that gives us a total of 256. Okay, but because we can represent 0 to 255, let's say that's with a bit weight of 1. So let's say that we wanted to represent a value not as necessarily one integer, so 0, 1, 2, 3, but we wanted to be able to represent a decimal point. So we wanted to have, we want to say, okay, it can be 0.5 or 1 or 1.5. Then we need to have a bit weight of 0.5. Okay, to be able to represent 0.5 in our values. So if we have a bit weight of 0.5, that means every bit value here is only going to have a value of 0.5 instead of 1. So instead of being able to represent 0 to 255, we can now only represent 0 to 127. Okay, but even though our data size in bits stayed the same, every bit or every value is only going to be worth or representing 0.5 now. So we are cut in half. So, but now we can say, we can have values of 0, 0.5, 1, 1.5, 2, going on up to 127. We can further increase this by saying, okay, we want a value of 0.1. Okay, so again, though, if we do that, we have 256 times 0.1, which gives us only a value of 25 here. Well, I think it's actually 25.5. So if we wanted to represent more than 25 with a value of 0.1, we'd have to increase our data size in bits. So in this case, let's say we do 2 to the 10th. Now we can represent 1,024 different values, but if we have a bit weight of 0.1, then what we can really say is, if we do 2 to the 10 bits, now we have a max of, we'll say 102. So we can represent 0 to 102, but we can represent each value in 0.1 resolution. So we can say, 0, then 0.1, 0.2, 1.1, 1.2. So we can continue changing the bit weights and resolution and data size to increase what we can represent with these virtual signals. Okay, so if you need more information about offset and bit weight, I would recommend doing some web searches things like that. It should better explain how these things work and how the data size in bits represents your min and max data range. Down here we can select what units we want to use. So we have, these are in metric units because here we've selected our base format to be unsigned metric. Let's say we go unsigned English. We'll have to change that back. And you'll see it changes everything back to the default values here. So once you change your base format, you may have to come back and change the values. But now we have English units. Like before we had kilometers an hour. Now we should have miles per hour somewhere in here. Yeah, miles a gallon, miles a pound, somewhere floating in here. I think I'm just missing it, but there it is. So we can change the format that we want. So we have signed values, which give us the ability to use positive and negative numbers. Unsigned, which means that our values are only allowed to be positive unless we do an offset to them. Character and wide character. These allow you to do strings, like store characters such as letters or numbers or special characters. So if you want to store, for instance, a name, you may use a character setting here. And then finally, load save. So load save is the way that you can store variables or virtual signals persistently. So if I click load save, this means that the tool will store this value past a shutdown. So this is helpful. So let's say you wanted to set up a password for a user, right? And your password's going to be 0 to 10,000 or 9,099, which essentially gives you a 4-digit password. That password, every time you shut off power, you don't want it to be erased, most likely. So the user can come in, change the password. So that, say they change it to, say by default we'll just do this. So let's say we're going to call this signal password. So to represent 10,000, we can do, we'll need 2 to the 14th. So we'll need 14 digits here, or 14 bits. Okay, and a bit weight of 1 because we don't need to represent decimal points with this. So we'll just say 0 to 9,999. So our password could be, 0000 or 1111, whatever we want in this range. Our units don't really matter in this case, so we can keep them as none because it's a password, so it doesn't really have units. And then finally, we want to load save this. So if the user goes and changes their password, so by default, it's going to be 0000. So say the user comes in and says, okay, I want my password to be 1234. Every time that the display restarts, if this is not checked, it will default to 0. So every time it restarts, the password would be 0000 again. But you don't want that. After the user changes it, you want their password to be remembered and saved past the shutdown. So that's why we're going to select load save here. And in future videos, we'll go over how to actually load and save that value correctly. But for this, just know that if you want it to persist past the shutdown, that we need to select load save. So in this case though, if we're just using this for storage in our current project and don't need it to save past the shutdown, which will be the case for most of our signals, we won't need it to save, then we can keep this box unchecked. Okay, that should cover it for virtual signals. As has been mentioned in previous videos, this help section here is, if we click that, it gives you, a rundown of different settings in the signal selection and all of the different types of signals. So definitely check this out for if you forget something along the way. We can click OK and save this project. And as always, we want to try to build just to make sure after we've done something that we're not breaking it. So it gives us a warning that we have not used these signals, and we know that, so no problem. Okay, that will do it for this video. Tune in for future videos. Thanks.